Hi, I'm Gabriel Barbu. My student ID is 228116855, and today I'll go through my project I've done for CSY 360. So my project is a face recognition project. We are predicting faces. I have three data sets in total. Everything is on Google Drive. So three data sets. One is with celebrities, 10 celebrities. One is with 10 celebrities where the pictures are cropped with just their faces, and a people data set where it's my face and my other friends' faces and parents. If I can show some examples really quick, all the pictures are super close and zoomed in, which we later talk why it's so important for them to be super close and zoomed in. Let's go to the other data. So the celeb data is a lot different. If I can show some examples. So these pictures are random with the celebrities from different ages. All images are randomly imported from Google with ImageEye. There are about 800 pics per person. Okay. And the last data set is with the celebrities, but the pictures are zoomed in and more easy to predict for the model. Okay. Let's run now through what I've done. So I have multiple models, about three models. First of all, what I've done is I reduced the dimension of the pictures, especially the ones I taken, because they were like 4,000 pixels by 3,000. We shrunk that down to about 250 pixels because it was much easier to work with pictures which are only 250 pixels instead of 3,000. You can see here all of them are pretty much the same, all files. They do differ a bit. So we import everything we need. NumPy, Pandas, everything we need, or TensorFlow, Matplot. Here we are loading the data. We are loading the dimension. And we are splitting the data. The data is already split into train, validation, test. Training is 70%, validation is 15%, test is 15%. We can see here the data set shape. Here are the amount of pictures, the image width, and the image height. And this is the filter of the image. It's only free because it's red, green, blue, the RGB filter to display the color. And we can see here some random pictures from everyone. So the first model is built by me. I selected the filters I want, the convolution filter, the max pooling. So it's really two main filters that I'm using. Max pooling 2D is where I'm shrinking the pixels. So we are working initially with 128 by 128. By using the max pooling filter, we are pretty much halving the pixels. Convolutional increases the amount of pictures color. So we have only three at the beginning. You can see here the RGB. And then by using this convolutional filter, it increases it to 32. And if we use it again to 64. So this is the main model I'm using. I use this model for all three data sets. Obviously, for the data set created by me and my friends, we achieved the highest accuracy. 95, it's always above 95 because the pictures are super closed up and the model uses only the pixels on the face, not the background or other things. It's really the validation accuracy we are looking for. This is the model, how well the model does on data it has never seen before. I'm not really interested in this accuracy here. And here we can see a confusion matrix. So we are looking for this diagonal line really. This is good. This is what we are looking for. It shows that, for example, let's see, so I'm number 4. So it predicted me 68 times, and 6 times is predicted me as my dad. This is the first thing I've done. Now I used the same model on the crop celebs. I've done pretty much the same thing. You can see it's different, less pictures. The image quality is a bit higher. Doesn't matter that much. I've tried different image size pixels. Doesn't affect that much. As long as it's between 64 and 256 pixels should be fine. So we have 10 celebrities. The pictures are the same, closed and zoomed in on only their faces. So the model should ideally only look for the pixels in the face. But I also use some data augmentation to prevent overfitting. So the same model you can see here, similar. And when it comes to training, I've trained it for a lot longer to see if I can achieve a higher accuracy. Now getting worse results compared to the pictures I've taken of myself. This worse result is due to the celebrities being a different age in some pictures, a different haircut. The women are using makeup, which is hard to predict. It's really even on your phone when you're about to set the biometrics on your phone. Once you close up, no makeup, no closed eyes, no crazy facial expression, and it warns you if your face changes a lot or you're using makeup or sunglasses, it's not gonna work. This is why it's super important for the pictures to be super close up, and so it's easier for the model to predict your face. Yeah, so I've achieved an accuracy of 46, which is expected. The data set is not as good as the data set I created. We can sort of see the diagonal line being formed with higher number than the rest, but it's not that clear as this one here. Yeah, so these are the celebrities and how accurate it was for each one. I also used different models. I used MobileNet V2, which is quicker, but and it did perform a bit better, 58 compared to 46, but it's more or less the same. We can see here the results. Let's look at this model really quick. Okay. Yeah, different set shape. We are using 80 pixels. I've tried different sizes. It just doesn't affect it that much, really, as long as it's above 64. So, fine. This is the code I used to split the data set into the ratio we talked before. 70% train, 50% validation, 15% test. I also use another model, GGG16. So all these files are pretty much similar, just different models, different pixel range. You can see this model is a bit more complex. Still performs similar. I've tried to do some fine tuning as well here, still ending up with the accuracy of 40. Yeah, so this is where I use the CNN I've created on the simple celeb pics. You can see these pictures are like random, whatever the Google search gave me. I just selected them all and see how it perform. Just out of curiosity, see how it does. And see like this picture is the face is not close and to the screen and the background is different. You can see obviously it will perform terrible compared to the dataset created by me. Yeah, so I've used some data augmentation. It haven't done anything drastically to the model and how it predicts. It did reduce the accuracy a bit less here, just to prevent overfitting, but nothing obvious to the accuracy has changed. We are rotating the pictures, we are widening them, we are zooming in sometimes, we are flipping them horizontally, vertically. I experimented with different augmentation strategies. Also, to see how my model perform and just out of curiosity, I did like a mid detector with which will activate my camera at the end and to show my right now it won't work because my webcam is working. I'll add another video separately. Okay, so you can see when I'm further away, it predicts worse. And when I'm closing in, performs a lot better because it only uses the pixels of my face, like my eyes, my eyebrows. When I am zoomed out, obviously performs worse, but it doesn't detect my face as well.